So I am looking at hi, ma'am.
Hi, teacher.
Hi, man. Man, you out there?
Yeah, I'm here.
Okay, perfect. It's just you and I, man. You, I, and some pretzels. God, no longer you and I, man. Oh, we got 3 here. Hi, guys.
Hi.
Oh, we're up to 4. How y'all doing?
I'm good.
Did you like that quiz question?
The one choice?
Yeah, that would be the one.
Yeah, I liked that quiz question a lot.
Let me put it to this way, Dana. If you got that one wrong, you flunked the course.
Okay, that's fair.
It really upsets me because that's my best question too. Had no idea what happened. Now we left off. I had gotten to the, where are my things? Oh God, I cannot have lost those. If I lost those, all hope is gone. What's your recollection of where we left off? Anybody?
I have no clue, honestly.
Last thing I remember was writing PO4 and PO3. The -3
I got into
charge.
nomenclature.
You got into something at the end that we got ahead of the other class with.
I have no idea where that went to. I had my okay. I'm sorry, I'm just I don't know where it went to. Okay. Was I into compound balancing?
Yes.
That's where I was?
Yeah, balancing compounds.
Okay, let's try and start with that then, okay?
Yeah, the last thing I wrote down was some polyatomic ions.
Okay, I got that far, huh? Wow. So there were these guys, right?
Yep.
Okay, so, all right, basically when you're balancing compounds, what you need to do, what you need to notice is the fact that the ionic compounds are always going to be neutral. positive charge equals the negative charge, right? I got through the weights, didn't I? I did the weights with you guys, didn't I?
Yeah, the demonstration, yeah.
Yeah, the weight demonstration. Okay. So there are going to be some cations that you know the charge for. Some cations you know the charge for, and there are going to be others that you have to figure it out. Does that make sense to you?
Yes.
Are we
Yes.
good there? So what we have to do is we know that the negative charge is going to be equal to the positive charge, or else the compound is going to be charged itself. So if we have a neutral compound, positive equals a negative. If the negative ion has the same charge as the positive ion, well, basically you're done, because the two charges cancel out. So if I have Na plus 1 and I minus 1, those go together. You put them together, we have a neutral molecule, NaI. Ba plus 2, S2 minus, put them together. There are no subscripts that are going to get involved because they both have the same charge. Same thing with Al plus 3 and N3. What happens is when the charges don't match, what you have to do is you have to think about how you balance the weights. All right, you have Al and Cl. Al has a charge of plus 3. Cl has a minus 1. So in order to balance the charge, you have to put 3 more negative chlorines in there to balance the 1, 3 plus aluminum. So you need to multiply the Al3 plus by 1. That was going to be the subscript for Al. And you need to multiply the Cl1 minus by 3. That's going to be your subscript for Cl. So the overall balanced molecule is AlCl3. Is this making sense, guys?
Yes.
Okay. Sometimes what happens is you have to go to the least common multiplier, least common multiple. For example, if we have magnesium 2 plus and phosphorus 3, the least common multiple is going to be 6. So what do you have to multiply magnesium by to get 6? 3. That becomes the subscript for the magnesium. The P3 minus gets multiplied by 2. That is the subscript for the phosphorus. When you are doing polyatomics, guys, they must be considered as a unit. Do not break them up. If the polyatomic is NO3, don't just say, oh, I don't need that one oxygen. I can make it NO2. When you make it NO2, you take it from being a nitrate to a nitrate. So the NO3, the 3 oxygens have to be there, and the N has to be there. You put the N and the 3 O's together, and you get a charge of -1. Again, aluminum has a +3 charge. So I need to multiply the Al by 1. That's the subscript for aluminum. And I have to multiply the NO3 by 3. The way I do that is I put a parenthesis around the entire NO3 and then put a subscript down below it. Dana, do you have a little brother?
No, I have a big sister.
Casey, do you have a little brother? Casey's gone off somewhere. Joe?
Yeah, what's
Little
up?
brother?
I have 2.
Oh, wonderful. Are they wonderful little tykes?
Never.
Yeah. So if you're going to go with the whole family up to Atlanta, are you going to leave the 2 nice little tykes behind? Remember what happened in Home Alone when the youngest kid was left in the big brother's room? Are you going to leave him behind, Joseph?
Well, I would, but no.
Joseph, if you leave them behind, they're going to get into your room and they're going to wreck it, right?
Yeah, true.
So you got to take them along. So think of a polyatomic like a family. If I'm going to take the N to Atlanta, I got to take the 3 O's also. The whole family is NO3. Everything gets put in the car parentheses. Does that make sense, guys?
Yep.
So if I have Mg and PO4, Mg is +2, PO4 is 3-. Least common denominator is 6. So I'm going to need to multiply the Mg by 3. That becomes the subscript for Mg. And I have to put the PO4 in parentheses because the PO4 is going to Atlanta. And I have to put a subscript of 2. So it's going to look something like this. Oh, okay. Does that make sense to you guys?
Yep. I have a question though.
Yep.
So what I like to do, what I learned is easiest for me is just like crossing the charges. Is that bad?
I'll tell you, it's going to, Dana, that will work 95% of the time. But I'm going to show you right now why it's not going to work 100% of the time.
Okay.
You do the cross multiplying there, right? Dana,
Yeah.
what's the charge on the lead?
I don't know. Hang on.
No, you're doing the cross thing, right?
Yeah.
So if you do the cross thing from the charges down, don't you have to also do the same thing from the subscripts up to get the charge? Right, Dana?
Yeah.
So if there is a 2 subscript on the O, what is the charge on the lead?
2.
And what's the charge on the oxygen?
1.
Oxygen can never have a 1- charge unless it is hooked to another oxygen. Oxygen will always have a 2- charge. So that's an example, Dana, where if you do it your way, you're going to get in trouble. As I said, 95% of the time, you're going to be fine with this. Okay?
Yep.
Same. If I want to do it the opposite way, if I want to say I have my PB is a 4+, and my O is a 2-. Right, Dana? You would
Yep.
do your cross thing, right?
Yep.
And you would end up with PB2O4.
Yep.
95% of the time it'll work,
Okay.
but there are some occasions when it won't.
And that's going to be specifically oxygen
Uh,
or the diatomic molecules in general?
Same thing will happen there. Okay?
Okay.
So it does happen. It's not often, but it does happen. Fair enough, Dana?
Yep. Fair enough.
So do it. Dana, if you're understanding it, do it. Just make sure you check. Oxygen can never have anything, cannot have a 1- charge. Sulfur can't either.
Okay.
All right. Now, we need to find the charge on the cation if it's a type 2 cation. I went through and told you the difference between type 1 and type 2 cations, guys. Did I?
I don't remember.
Do you know? Well, Dana, what's the difference? Type 1 or type 2?
I know type 2 is like more in the middle of the periodic table, and and some of them have like different charges sometimes.
Most of them have more than one charge.
Yeah.
Okay? Because they have more than one charge, we have to determine what that charge is. Okay? And the way we do it is we add up all the negative charges in that particular compound. And because the compound is neutral, the total negative charge has to equal the total positive charge so that they cancel each other out. So we're going to use the anion to figure out what the charge of the cation is. All right, we have cobalt sulfate. SO4 has a 2- charge. We always know what the charge on the anion is. There's no parentheses, there's no subscript, so SO4. So I know that my SO4, I have one of them, it has a -2 charge, so that is my total negative charge. Therefore, the total positive charge must be a +2. So I take the fact that my cobalt is a +2, and I'm going to divide it by the subscript. There's only one cobalt. So +2 divided by 1, that makes the charge on the cobalt a +2. Okay, we have Fe2SO4 taken 3 times. The total negative charge on each SO4 is a 2-, and there are 3 of them, so there's a total negative charge of 6-. That means that the total positive charge has to equal it. The total positive charge is a +6, but that's distributed between 2 irons. So I take the +6 divided by 2, the charge on the iron is a +3. Is that making sense to you?
Yeah.
Yes.
Yeah.
Okay, I got to do a little bit of a sidelight here. Empirical versus molecular formula. An empirical formula is the smallest ratio of atoms in a molecule. A molecular formula is the actual number of atoms within the molecule. So basically, you multiply the empirical formula subscripts by one whole number, and you will get the molecular formula. Carbon dioxide. Each molecule exists of 2 atoms of oxygen and 1 atom of carbon. That is the smallest ratio. It also happens to be the actual number of atoms in a carbon dioxide molecule. So the empirical formula and the molecular formula are the same. I can do the same thing for water. Water consists of 2 atoms of hydrogen, 1 atom of oxygen. The empirical and molecular formulas are the same. But if we go to hydrogen peroxide, this consists of 2 atoms of hydrogen and 2 atoms of oxygen, or H2O2. I can divide both of those subscripts by the same whole number too. And if I do it, I get the empirical formula of HO. If I have a glucose, the molecular formula is C6H12O6. I can divide all those subscripts by 6 and end up with CH2O. That is the empirical formula. Are we good with that, guys?
Yep.
Gene. Sorry, Casey, that your mic doesn't work.
I have a question.
I have an answer.
So why does the empirical formula even matter?
Why does it matter? Because you can figure out lots of things from it. For example, we're going to get into empirical formula data. I'm guessing it's the last subject we covered before the test. So September 10th, we're going to be getting to that. Okay? Rebecca?
Yep.
And sometimes when you do analysis, what happens is you can calculate what the empirical formula is, and you have to know what the molecular formula could be to interpret what the molecular formula actually is. Does that kind of make sense to you, Rebecca?
Yeah.
All right, I teach nomenclature probably a little bit different than you had it taught before. And basically the way I teach it is I go through a series of questions. Do you see the nomenclature slideshow?
Yes.
So we do.
Okay. I like to go through a series of questions. And if you keep this series of questions down, you're going to get the naming correct. We're going to deal with naming ionic compounds, naming molecular or covalent compounds, and we're going to get the name of some acids. Now, basically, within ionic compounds, we have two different classes of compounds. The ones with the type 1 metals, the ones in which we know the charge, and the type 2 metals, the one in which we don't know the charge. Acids, we have two different types. Those are the acids with oxygen. Those are the acids without oxygen. And the binary non-metal compounds are basically non-metals bonded to non-metals. All right, if we are getting into naming a compound, we have a formula. We have a formula and we want to get the name. The first question you ask yourself, look at the first element in the compound. Ask yourself, is the first element a metal? If it is yes, you use ionic rules. If the answer to that question is no, you use covalent rules. All right, we're going to start with ionic rules first. All right, we have a second question then. Can the metal form more than one type of cation? If the answer is yes, you need to determine the charge on that cation. Then you need to name that element with a Roman numeral that indicates the charge of the cation in parentheses after the element name. If the element can only form one cation, then just use the element name with no Roman numeral. If it's a type 1, again, we're going to just name the element name. Guys, I'm lazy. If I know what the charge is, why do I want to go ahead and write the charge again? If I have a sodium, I know that the sodium always has a +1 charge. So why would I have to write sodium, parentheses, Roman numeral 1? It's not necessary. It's redundant. So for type 1 elements, you don't use a Roman numeral. Type 2, you got to figure out what the charge is. Then you absolutely have to include the element name, then the Roman numeral in parentheses, indicating the charge. When we're dealing with ionic compounds, we're talking about electronegativity differences, 2.0 or greater. Basically, we are talking about metals and nonmetals. Ionic compounds have two parts to their name. You name the cation first, then you name the anion. You name the positive ion first, then you name the anion. Two types again, type 1 and type 2. So how do we tell what's what? If your metal is in the first column to the left of the periodic table, if it's an alkali metal, then it will always have a 1+ charge. If it is in the second column from the left, did I say left before? Guys, if it's in the first column on the left, it's an alkali metal, always has a 1+ charge. Second column, it's an alkali earth, always has a 2+ charge. Then we have our special metals. Silver is always +1. Zinc is always +2. Aluminum is always +3. If you look at the periodic table, they go in a slanted line, aluminum, zinc, and silver. Bismuth will always be a +3. Cadmium is always a +2. The other type is a type in which the charge is not known. Basically, we are dealing with the transition metals. Type 2 is anything that does not fall under the category of the type 1. To name type 1 cations, just simply name the metal ion. I have AgCl, that's silver. I have CdCl2, Cd is a type 1 element. It is cadmium. MgSO4, Mg is in the second column. It's also known, charge is known. So therefore, it is called magnesium. Joseph, first compound up here. All you need to do is name the cation.
Sodium.
Is the first element a metal?
Yes.
Is it a type 1 or is it a type 2 metal?
Type 1.
Then name it.
Sodium.
Dylan, second one. Is it a metal? Is Ba a metal?
Yes.
Okay. Is it a type 1 or a type 2 metal?
Type 2.
Where's barium at in the periodic chart, Dylan?
Type 1, sorry.
Type 1. Do I need a Roman numeral?
No.
So it's just called barium. Rebecca,
Yep.
AgNO3. Is Ag a type 1? I'm sorry, is Ag a metal?
Yes.
Is it a type 1 or a type 2?
Type 2.
Okay. What were the special ones I told you about? See the
Silver
slide,
is one.
Rebecca?
Yep. Silver is one of them. It always has a +1's charge.
So do I need a Roman numeral for that?
No.
Okay. We're going to go Dana. Is the first element a metal, Dana?
Yes.
Okay. Is it a type 1 or a type 2?
Type 2. Or
What's your second guess, Dana?
type 1.
Type 1. Does a type 1 cation need a Roman numeral?
That one does.
It does?
No, it doesn't. Sorry.
Type 1 will never need a Roman numeral. I'm lazy, Dana. I don't want to have to write that 2 I's. It's going to give me arm fatigue.
Okay.
If we have a type 2 cation, we got to name the metal followed by the charge written in Roman numerals in parentheses. So if I have CuO, I know that oxygen will have a -2 charge. The subscript is 1. 1 times a -2 is a -2. That is balanced by the positive 2 that must be there. That positive 2 is divided by 1. The charge on the copper is a +2. So I call this compound copper 2. Fe3N2. N has a -3 charge. -3 times the 2 nitrogens gives me a -6. So the positive charge that balances with that is a +6. But that +6 is distributed in 3 ions. So I divide the 6 by the 3. I have iron 2. COS2. S2 or S has a 2- charge on it. There are 2 of them. So the total negative charge is -4. I have to balance that with the +4. So I get +4 divided by the subscript on the cobalt is 1. I have cobalt 4 sulfide. Okay, I just went through those 3 slides. All right, do we basically understand how we get the charge? And do we basically understand that type 1s do not need a Roman numeral, type 2s do? Are we good there?
Yes.
Yeah.
All right, so that's half the name. Half the name for ionic compounds is done. All right, we go to anions. There are 2 types of anions. First is a monoatomic. A monoatomic will always have 1 type of element, like Fe3S2. Fe2S3. There are 3 sulfurs there, but it's only sulfur that makes up that anion. Only 1 type of element. So if there's only 1 type of element, it's monoatomic. If it's polyatomic, that means that there is more than 1 element that makes up that anion. Monoatomics, to name them, you take the first syllable of the element. If we have oxygen, that's ox. If it's sulfur, it's sulf. If it is nitrogen, it's nit. You take the first syllable. Does anybody not understand what a syllable is? And it's a silly question, I know, but I had somebody in my earlier class that didn't. Anybody not know what a syllable is? Finest kind. So we're going to take the first syllable of the element, throw out the rest of the name, and we're going to add IDE to it. So if I'm going to name this compound, all right, is the first element a metal? Dylan,
Yes.
is it a type 1 metal or is it a type 2?
Type 1.
Type 1, it's one of the special ones. Do I need a Roman numeral, Dylan?
No.
Okay, so what's AG, Dylan?
2 plus.
Somebody needs to study their elements. Somebody help them. AG is what?
Over.
It's right on the slide, for God's sakes.
+1.
What is AG?
It's silver.
Thank
Oh,
you
silver,
so
yeah.
much. It's on the slide. All right, so silver, but I don't need a Roman numeral because it's a type 1. All right. Now, Dylan, I still need you. What's the first syllable for oxygen?
Ox.
Ox. Add what? What do you add to it?
Ide.
Oxide. So the whole name is silver oxide. Min. You out there, Min?
Yeah.
Min?
I'm here.
Okay, good. SnCl2. Is the first element a metal?
Yeah, it's a metal.
So do I use ionic or do I use covalent rules?
Ionic.
Ionic, good. Now, next question. Is tin a type 1 or is tin a type 2 element, metal?
Type 2.
Type 2. What do I need? What do I need with a type 2, man?
It is a numeral.
I need a Roman numeral. Okay. Chlorines have a -1 charge, man. So if I have 2 of them, what's the total negative charge?
2. 2
Okay.
negative.
So that -2 corresponds also with a positive 2. How many tin atoms are in the compound?
1 atom.
1 atom. So that 1 atom has a +2 charge. What do I call the cation?
Tin 2.
Tin 2. Okay, the second half of this. What's the element Cl?
Chlorine.
Chlorine. I take the first syllable, chlor, and I add IDE. So the total name is what, men?
Tin 2 chloride.
Tin 2 chloride. Now, polyatomics are easy. To name them, you just use the polyatomic name. SO4 is sulfate, so ZnSO4 is zinc sulfate. Zinc is a type 1 cation, no Roman numeral. NO2 is nitrate. So FeNO2 taken twice. NO2 has a -1 charge. That makes the total negative charge -2, which balances with a +2. There's only 1 iron there, so that 2+ is distributed in 1 atom. That's iron 2 nitrate. Okay. Blake, you have number 1. Dana, number 2. Dylan, number 3. Jackson, number 4. Joseph, number 5. Casey, I want you to print out the name of number 6 in the chat room. Min, you have number 1. Nathan, number 2. Rebecca, number 3. I want you to name the number I gave you. I want you to determine what the name of that cation is while I munch on a pretzel. Maybe 2 pretzels. Enough time, guy? Enough time, guys?
Yeah, I'm ready.
Okay, who are you?
Blake.
Okay, Blake. Blake, you have which number?
I had the first one.
Okay.
It's
All
silver bro.
right, let's do this. Again, we're going to do it systematically. Is the first element a metal?
Yes.
Therefore, we use ionic rules. Is the first element a type 1 or a type 2?
Type 1.
Does it need a Roman numeral?
It does not.
So, name that compound.
Silver bromide.
Silver bromide. Who's got number 2?
Dana.
Dana.
I do.
And Min?
Nathan.
Nathan. Dana and Nathan. Is the first, I need stereo, guys. If I don't have stereo, I'm going to make you keep on doing this. Harmony would be nice too. Is the first element a metal?
Yes.
Not too good on the harmony. So it is a metal. Is it a type 1 or a type 2 metal?
Type
Type
1.
1.
Dana, what'd you say?
Type 1.
Good. Okay. Does a type 1 metal need a Roman numeral?
No.
No.
So, name it.
Sodium sulfide.
You agree, Dana?
Yeah.
Fine as kind. Who's got number 3?
Rebecca.
Rebecca, is the first element a metal?
Yes.
Is it a type 1 or a type 2 metal?
Type 1.
Does it need a Roman numeral?
No.
Okay. Name it. Do you know what
Calcium.
NO3 is, Rebecca?
Nitrate. It's one of the polyatomic
Good.
anions.
So name it.
Calcium nitrate.
Simple enough, guys. Who's got number 4?
Jackson.
Go for it. Is the first metal, is the first element a metal?
Yes.
Use ionic rules. Is the first element a type 1 or a type 2?
Type 1.
Okay. So if it's a type 1, does it need a Roman numeral?
No.
All right. Name it.
Potassium sulfate.
Potassium sulfate. Who's got 5?
Joseph does.
Joseph, you got the name?
Yeah.
What is it?
Aluminum hydroxide.
Aluminum hydroxide. Who's got 6? Nobody's got 6?
It was what you call it? I had it.
Chat
Oh, it's
room.
Casey?
Yeah.
Oh, okay. Maybe she's done it on the chat. I'm not seeing a chat, guys. Does anybody see
There you
if
go.
she's done it?
I don't know.
Okay. In any case, this is going to be calcium iodide. Let's look at this compound. Rebecca, is the first
Yes.
element a metal?
Hold on, I just lost my periodic table.
Dear God, never lose your periodic table. I'm taking mine to my coffin.
It is.
I'm not.
Is it a type 1 or a type 2 metal?
Type 1.
He's hesitating, Rebecca. What happens when he hesitates?
I don't know what happens.
Oh, bad things. Okay. Is lead in the first column?
No.
Is it in the second column?
No.
Is it silver, zinc, aluminum, bismuth, or cadmium?
No.
So is it a type 1 metal?
No. It's type 2.
What do you need with type 2 metals?
Roman numerals.
Roman numerals. What do you do to get the Roman numeral?
You look at the charge of the anion.
Well, you need the charge of the cation. The charge of the anion is not going to give you the Roman numeral. You can figure it out from that, but it's not directly that number. So Rebecca,
Yes.
oxygen has what charge?
A -2.
How many of them do I have?
2.
So what's the total negative charge?
-4.
That balances with?
Lead.
It balances.
Right.
The -4 has to be balanced by the same number of positive charge, right?
Yes.
So the lead has to be 4 plus. How many of them are there?
1.
So name that compound.
Lead oxide.
What you miss?
Oh, lead 4 oxide.
There you don't go 4. Be positive.
Lead 4 oxide.
Give me lead 4 oxide. There you go. Absolutely. NiSO4 taken 3 times. We're going to go with Nathan on this one. Nathan,
Yes.
is Ni a metal?
Yes.
I certainly hope so. Is Ni a type 1 or a type 2 metal?
Type 2.
What does it need?
Needs a Roman numeral.
So SO4 is a -2 charge. How many of them do I have?
You have 3 SO4s.
So what's the total negative charge?
-6.
That balances with a positive.
6.
How many nickels is that distributed amongst?
2.
So what's the charge on each nickel?
It should be nickel 3.
Okay, so name the compound.
Nickel 3 sulfate.
There you go. Again, we're going to do the same thing we just did. And I lost a participant. Blake, you're number 1. Dana, 2. Dylan, 3. Jackson, 4. Joseph, 5. Min, 1. Nathan, 2. Rebecca, 3. I want you to name those compounds. Anybody ready? Geez, this is the third pretzel, guys. I'm gonna
I'm
get
ready.
fat while you guys are just lolling around here. Somebody ready?
Yep,
Right.
Blake's ready.
Blake, you had number 1?
I did.
Okay, go for it.
You just want the name? It'd be manganese nitrate.
Is manganese a type 1 or a type 2 compound? Is manganese a type 1 or a type 2 metal?
Manganese. It's a type 2.
So what's it need, Blake?
The Roman numeral, which I thought it was a 1. So, mag.
2.
Is it 2?
NO3 is a -1. Okay, Blake. NO3 is a -1. How many of them do I have?
You have 2 of them.
So what's the total negative charge?
Be -2. So
That-
manganese would be a positive 2.
So name it.
Name it. Manganese.
Nitrate.
There you go.
Okay.
It's safe.
Who had the second one?
I did.
Whose I did?
Nathan.
Thank you, Nathan. What is it?
Antimony.
Antimony?
Antimony 3 phosphate, I think.
Anybody have any objection to that? Okay, number 3. Who had number 3?
I did.
Okay, Dylan.
Copper 1 oxide.
Copper 1 oxide. Who had number 4?
Jackson did.
Jackson, what is it?
Chromium 4 acetate.
And the last one, number 5.
Mercury 2 nitride.
Yep. I had to sit here and think there for a second. You're absolutely right, Joseph. Same thing. Number 6 would be tin 2 phosphite.
Yes.
All right. Now, we went one way. Now we got to go the other way. We were able to name the thing from the compound. Now what we have to do is we have to derive the formula from the name. And actually, it's a lot easier going in this direction. Potassium hydroxide. What's potassium's form? What is its symbol?
Okay.
Okay.
All right. What charge is on potassium?
+1.
All right. Hydroxide. What's hydroxide of the polynomial look like?
OH.
OH.
Do you know what the charge on OH is?
-1.
Yeah.
So if I have potassium hydroxide, what is the formula?
KOH.
KOH. All right. I have tin 4 chloride. What's the charge on the tin?
+4.
+4. Amazingly enough, it works out. So tin is a +4. What is chloride?
Chlorine.
What's the charge on chloride? Not chlorine. What's the charge on it? Dana?
-1.
-1. So if tin is a +4, chloride is a -1, what is my formula going to be?
CL. Oh wait. N.
PB.
CL4.
PbCl4, yeah.
No. PB is lead.
Oh.
Said 10.
SN.
SN.
Methane.
SN. There we go.
SN what?
CL4.
SnCl4. Iron 3 acetate. What's the charge on the iron?
3.
Okay, acetate is
-1.
-1. So how many acetates do we need?
3.
3.
Fe, parentheses, C2H3O2, in parentheses, 3. Aluminum sulfate. What do we got? What's the charge on aluminum each and every time?
Well, 3.
3. I don't need to put the 3 in there because it's a type 1. So if aluminum has a +3 charge, what does sulfate have?
-3.
-2.
-2.
-2. So what are my subscripts on aluminum sulfate?
Two on aluminum, 3 on sulfate.
2 on aluminum, 3 on sulfate. Al2, parentheses, SO4, and parentheses, 3 times. Formula for nickel 3 nitride.
Should be NiN.
NiN. Nickel has a +3 charge. Nitrogen has a -3 charge. So you just need one of each, NiN. All right. Now, if the first question we get, is there a metal present? If the answer to that question is no, we are dealing with covalent compounds. Covalent compounds use prefixes. Ionic compounds, if there is a metal present, you never use prefixes. If there is no metal present, then you use prefixes. All right, we have no metal present. We look at the first element. If it has only one atom, just name it. If it has more than one, you precede it with the correct prefix and add the name. So we've got the first element named. Now you got to look at the second element. The second element will always, always, always take a prefix. You look at the root of the name, the first syllable of the element name, and add IDE. First element's always named first. If the subscript is greater than 1, use a prefix. Second element, the body is the first syllable of the element name. It's preceded by a prefix, and you add IDE at the end. The prefixes, 1 for mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 hexa, 7 hepta, 8 octa, 9 nona, 10 deca, 11 predicata. There is no 11. If if your professor is sick enough to give you one with 11, God bless you. I will not do that, okay? So if we're naming them, I've got a molecular compound. First element is carbon. Carbon is not a metal. So I use covalent rules. That carbon, there's only one of them. So I have no prefix. The name of the first element is carbon. Second element, the body is oxygen, first syllable of oxygen, ox. The subscript indicates a 1, so its prefix is mono. It ends in IDE. Okay? Guys, you have to be, some of these names are kind of a little bit funny. You don't want to say monooxide. It's just monoxide. If you have two vowels that are together there from the prefix and the name of the element, just drop the prefix vowel. So if I'm looking at this compound, this is carbon monoxide. Okay, guys? First element. Is the first element a metal?
No.
Use covalent rules. That means we're using prefixes. How many of the first element are there?
2.
Got to use the prefix di followed by the name of the element, nitrogen. So I've got dinitrogen. How many oxygens do I have? You're fading on me, guys. It's only been 55 minutes. How many
4.
oxygens?
4.
4, thank you. What is the prefix for 4?
Tetra.
So I have dinitrogen tetra,
Oxide.
dinitrogen tetraoxide. Warning, guys, if a metal is in the formula, do not use the mono, di, tri prefixes. If it's a metal, it's an ionic compound, use those rules. Okay, again, we're going to distribute these. Hey, I still got everybody. Still got everybody here, except I think Casey dropped. Blake, number 1. Dana, number 2. Dylan, number 3. Jackson, 4. Joseph, 5. Min, 6. Nathan, 1. Rebecca, 2. I only got 6 pretzels left, guys. Okay, what do we got for the first one?
Would it be tetraphosphorus decoxide?
That sounded revolting, but it's right.
Yeah.
Second one.
That was me. Is it sulfur hexabromide?
Good job. Number 3.
Dichlorine heptasulfide.
Number 4.
Calcium bromide.
Ooh, somebody got it. Calcium. Somehow you guys look at calcium and you want to make it a non-metal. Calcium is a metal. Yes, you named it correctly. It is calcium bromide. It's an ionic species. You do not use the prefixes. Number 5.
Carbon iodide.
And the last one. Where you at, man? Okay, let's do it together. How many sulfurs?
3.
3.
What's the prefix?
Try.
Tri.
Tri, sulfur. What's the next one?
Tetra.
Tetra,
Nitroxide.
nitride.
Tried there.
Okay, I know this is it's probably my most thrilling class that I teach. What's the formula? Dylan. Carbon dioxide, what is the formula?
CO2.
CO2. Joseph, sulfur tetrafluoride.
What up? Sulfur. No, I mean
Tetrafluoride.
SF4.
SF4. Okay, Rebecca, number 3.
Cl 2 I7.
Here you go. We're going to go with Nathan, number 4.
It's gonna be P and then CL5.
PCl5. And Jackson, number 5.
H2O.
H2O. Yes, the real name for water is dihydrogen monoxide. And last one, hexasulfur nonabromide. Somebody yell it out.
S6. I feel like I should let you go. BR10.
Almost. The S6 is right. No,
BR9.
BR9. Okay?
Okay.
Last one we're going to get is we are going to start to name the acids. The last thing we have to do. If you look at an acid always begins with hydrogen. There are only 2 compounds I know of that begin with hydrogen that are not acids, and that is water and hydrogen peroxide. So the formula is always going to have a hydrogen in it. There are 2 types. One are the binary. The other are called the oxyacids. So if you're naming an acid, you got to ask yourself, does the acid contain oxygen? If it's no, you name it by saying hydro, whatever the anion first syllable is, ic acid. If the anion does have oxygen, you got to check the ending of the anion. If it is ite, it is the root plus OUS plus acid. If it's ATE, it is the first syllable plus IC and acid. Note, the oxyacids do not use a hydro. So if we're going to name binary acids, first part, hydro. Second part, whatever the anion's first syllable is, you put that in there. Third part, you add IC, then add the word acid. Sometimes you have to add another little syllable in there. So we have HCl. First part is hydro. The other element is chlorine, so we use chlor, add IC, then the word acid. Hydrochloric. Ew. I don't know what happened there. Hydrochloric acid. If I have H2S, first part, hydro. What's the syllable of the second element, Joseph?
Sulf.
Sulf. Hydrosulfic acid does not roll off the tongue. So we have to add another little syllable in there. So this is going to be hydrosulfuric acid. Do you guys have your periodic table still handy?
Yes.
All right, look at the upper right-hand corner. NH3 is a base. You will not call it an acid. Never, ever. Okay? The next one over is oxygen. H2O. You are not going to call it hydroxyic acid. Never, ever. You will never hear it called that. Some odd people may call it dihydrogen monoxide, but you will never get anybody to call it hydroxyic acid. So you don't have to worry about the oxygen. You do have to worry about the fluorine, hydrofluoric acid. Okay, right below oxygen is sulfur. We just went through that, hydrosulfuric acid. Right to the left of the sulfur is chlorine, hydrochloric acid. H2SE, hydroselenic acid. We go right to the right of that, Br, HBr, hydrobromic acid. And then right below hydrobromic acid is hydroiodic acid. That's all you got. So those are all the binary acids that can be. We good? Are we good, ladies and gentlemen?
Yeah.
Funny enough, oxyacids are acids with the anion having having oxygen in it. These are polyatomic anions. Remember two sayings. I ate it and it was icky. If the anion name ends in ATE, change it to IC and add the word acid. Note, oxyacids, you are not using hydro. You may need to add a syllable. SO4 is sulfate. Drop the ATE and add ic. Sulfic doesn't sound good, so they added another syllable, sulfuric. HNO3. What's the anion? NO3.
Nitrate.
What do you drop from nitrate to make it to name the acid?
ATE.
ATE. What do you add?
Ick.
Nitric acid. Okay? If I have H, C2H3O2, C2H3O2 is acetate. So we drop the ATE and add IC, acetic acid. Are we good with this? H3PO4, you have to add another syllable. That becomes phosphoric acid. Okay, if you didn't eat it and it wasn't icky, if you took a bite and it was delicious, then if the anion ends in ITE, change the ending to OUS and add acid. So the anion PO4 is phosphite. It gets changed to phosphorus acid. Phosphoric acid just doesn't sound well. If I have HNO2, that is nitrite. Drop the ITE, it becomes, drop the ITE, and it becomes nitrous. So HNO2 is nitrous. Do you need practice on this, or do you think you got it pretty well?
I think I got it.
Okay,
Same.
same.
I think we're good.
That's where I'm going to end it. Basically, the morning group is caught up because I stayed with them 25 minutes extra today. So you're both at the same spot. And we are going to talk about chemical reactions on Thursday. I
Yeah, I had
have basically 2 days of chemical reactions.
I had a question about that. On the lab, they have you do like a, they had you do a I think it's a hydrocombustion reaction. And they didn't give you any like in the lab, they did, in one of the drop down menus or something, it helped, they gave us like an example of equations about double displacement reactions. But they didn't give us any example for hydrocombustion. I was able to get the answer right.
Hydrocombustion. I don't understand what you mean.
I might be saying that right. Wrong. It's a
A
combustion.
combustion reaction?
Yeah, maybe that's what it is. Yes, I just know that it ends up like the reactants give H2O and I think CO2 at the end. Or
Exactly.
Something of the sort.
Nathan, you don't have me for lab, do you?
No, I don't. I have Professor Warden.
Okay. I made a statement in the lab. I don't agree with them showing you the reactions this early.
Okay.
Does Dr. Warden seem like he's a little bit ahead of us?
I mean, not necessarily. Like it was literally only maybe one question, and I was able to just figure it out because I actually took him for intro last semester. So he gave us a whole binder on like different sections of the chapters, but I just went back and I ended up like finding what type of reaction it was, and I figured it out. But I didn't know if there was I was just making sure that I wasn't behind.
No, you're not behind, Nathan.
Okay.
Basically, I that lab is the second week of the semester. There's no way in the world anybody can
Yeah.
get to reactions within the second week of the semester.
Yeah, because the first week is the syllabus. Yeah, that was just.
So basically, I think it's unfair, and I called it unfair. And everybody in my lab, I went through and kind of showed what you had to do with that.
Okay.
So
Well,
I apologize, Nathan, but
no, it's okay. It's okay. I just wanted to make sure I was on the right page.
no, you're on the right page. It's if it's any, you're being all treated the same anyway, Nathan.
Okay. Yep.
Anything else, ladies and gentlemen? Glad to have nomenclature back. Glad to be done with it.
Yeah.
Seriously, did this help? First of all, was it taught the same way that your last instructor taught it?
No.
Was it helpful, Dana?
Yes.
I'm not looking to get pats on the back. If it's not working, tell me.
Okay, yeah, no, I get it. I actually did have a question though. So
I'm here.
just the difference between an acid and like a ionic or covalent compound, just the fact that it has hydrogen in it.
It's a specific ionic compound. Okay,
Oh.
Dana? These
It just said-
compounds, all these compounds you see up here, they are literally ionic compounds.
Okay.
It's just that it's a specific ionic compound with the cation always being H.
Okay.
All right?
All right. Thank you.
Anything else, ladies and gentlemen? Remember, if you have the lab, we agreed to meet at 7:15. Okay? If you have the lab, we're Zooming at 7:15. Other than that, guys, bye-bye. I will see you on Thursday.
See you Thursday.
See ya.
Okay. Take care,
Bye.
guys.
Take care.